So today I'm going to present how you can maintain your full operational flexibility with the most affordable fuel oil after the global sulfur regulation cap. My company is DuPont. We have an history of about 2 centuries. We started with the chemical as a pure chemical industry. Now we moved to the integrated science. That means also chemistry applied to agriculture, materials, and also clean technologies. I'm proud to say that we have 13 innovation centers all over the world. My business is the clean technology. We are a global leader in sustainable process technologies. We serve many industries, including the marine. I'm currently promoting the marine scrubbers, the safety, energy, environmental consulting, and then protection devices for shipyards and ship operators like the Tyvek and the Nomex. I will start with some figures about the SOx emission from the shipping industry that accounts, let's say, I want to say only, but it's the 6% of the global SOx emission, including the natural SOx emission. But if you look at the amount of the fuel that the marine industry burns with high sulfur content, it's around the 70% of the total petroleum consumption. And if you compare the marine industry to the automotive, for example, or the aviation, unfortunately, the SOx emissions are so great with the ships, as opposed to the carbon dioxide. So the path to a zero sulfur emission industry, marine industry, is well set. Started last year, January 2015, and targeting a global cap of the 0.5% within the 2025, with an intermediate but challenging step for the world marine industry, because starting from the 2020, for sure, the European Union will implement the 0.5% limit, as well as China and Hong Kong, while the Baltic area and the North America are in place since last year. There are several compliance options. This is not my opinion. This is opinion of Glowstein. He's an independent marine consultant. First of all, you have the usage of distillate fuel oil and also the branded marine fuel, like the hybrid fuel, ultra-low sulfur fuel, or the ECA fuel. There are some advantages, for sure, common advantages. The simplified fuel and waste stream operation. You don't need to treat any water. You have a limited capital expense to retrofit a dedicated MGO circuit on board. And there is no cargo space loss. That is one of the most important things. There are big challenges. The high fuel cost, because the differential between heavy and light fuel oil is still more than $150 per ton. The lower lubricity compared to the high sulfur fuel and the wax formation. Talking about the branded marine fuel, you also need to challenge the small availability that is limited to specific ports. So if you travel between, let's say, Rotterdam to Hamburg, maybe it's okay, but it's limited to specific ports. Then we also have the liquefied natural gas, obviously. Great advantages. It's likely to maintain the long-term fuel price advantage. Also a clean burning, because you can address the NOx and the SOx regulations at the same time. But the NOx regulation only applies to the new building. The challenge is, okay, supply chain not well developed, but it will be 100%. The conversion, the retrofit are not that attractive because it's 3 more expensive compared to an exhaust gas cleaning system. And you have 7 times the cubic footprint to fit the gas tanks. I will say that for a retrofit, it's not that convenient. Regarding the exhaust gas cleaning system, that's the reason why I'm here, you can always burn the low-cost fuel that has a great availability. And you can save a lot of money in the short term, not in the long term. Challenges, you have an initial capital investment, but also you can finance the equipment. You have the wastewater management, a slight increase of operation complexity, and the wastewater management. In the end, what counts most is the operator's point of view. Thanks to Lloyd Register that made a sulfur survey last year, if you look at the strategies that operators think will be most suitable, viable for the future after 2020, we can see that the natural gas and the exhaust gas cleaning systems will be the most popular in the future. This is not our point of view. While since 2015, the marine gas oil, the distillate fuel, are more popular. So what are the exhaust gas cleaning system, the scrubbers? Scrubbers are an effective and IMO-approved SOx abatement devices that use alkaline water, such as seawater, that convert harmful SO2 into harmless aqueous SO4 sulfate that are naturally contained in the water. There are also added benefits, great added benefits. First of all, the acid rains prevention, the particulate removal, and the noise attenuation. This map is showing our experience of executed projects in land-based and marine application from scrubbing system. We have great experience in America, as well as in Far East and Europe. There are 5 essential components of a scrubbing system, well known in the marine industry. A source of water, seawater or fresh water plus a base reagent, centrifugal pumps, the scrubbing tower itself, the treatment plant for the wash water, and the monitoring system. That is the most sensitive part of the whole thing. Monitoring is essential for water and air. There are 3 typical operating modes. The open loop is the easiest. You only use seawater and use the alkaline to abate the pH, the acidity. So there are no chemicals used in the system. Then you can also have the closed loop where you use only fresh water plus a chemical to abate the pH. The system is not subject to alkalinity or water temperature, so you always maintain a good efficiency in the process. So the capital expense is also lower because you don't need material to sustain the chlorine content on the seawater. Then you have the most flexible solution, that is the hybrid, that is the favorite in the Baltic area, because you can use a combination of both the operating modes. There are mainly 2 design configurations. The first is the single stream. The single stream is good because for specific ship type, like the cruise and the ferries, where you have multiple casing or funnel, you can fit easily the tower for each source. So you reduce, in that case, the amount of the installation cost because you don't need to cut a lot of steel. While for the cargo ship, the multi-stream is the preferred solution because you just have one funnel at the aft side of the ship and you just need to insert the scrubber from the top on the funnel. In that case, you can also treat multiple sources with the same tower. You can treat auxiliary engines, main engine, and boilers with the same tower. Our key benefit is that we have a slim and customizable solution, low pressure drop. You don't need any additional fan in the exhaust gas line. You can run the system in a dry mode if you are outside an ECA area. So you just switch off the pump and the water, and you can run the exhaust gas through the tower. We engineer the system in US, and we can fabricate wherever you want, close to the shipyard. So you can also survey the process. Only? My gosh. Okay, this is just a case study, just one because the time is running out. This is for an Aframax tanker. In that case, the typical propulsion is one main engine, 2 strokes, 14 kilowatt, electricity generation with 3 auxiliary engines, 1 megawatt each, with an annual fuel consumption of 10,000 tons of heavy fuel oil. Assuming a price differential of 175 USA dollars per ton, By running with heavy fuel oil instead of marine gas oil, you can save up to $1.4 million per year. And if you assume an installation cost that is the 50% of the equipment cost, the return of the capital expense is just 2 years. Considering the whole life of a ship, if you are doing a retrofit, in total you can save $21 million for the whole life. Typical configuration, as I mentioned, is just one tower connected to all the sources that we have on board. 3-meter diameters, 10 meters height. That's it. This is another case study for a bulk carrier. You can look at the website if you want to go in. And I want to make some reflection about the installation cost, because it's a great part of the game. And this has different impact to the return of investment, for sure. If we talk about a new building from a scrubber-ready project, the installation cost is much less compared to a retrofit if you are doing an on-purpose dry docking. This is why, if you plan in advance to put an exhaust gas cleaning system, you can save a lot of money in the installation costs. Because if you do the retrofit during a scheduled dry dock, you can save a lot of money. If you think about the new building in the future, and you have a scrubber-ready project, it's very simple to implement this kind of equipment. Also, the ship type has an influence on the return on the investment. For a tanker or a bulk carrier, the installation costs are much lower compared to a cruise or a ferry, because you don't have superstructure. You just fit the scrubber from the top. Scrubbers are an excellent compliance option because the payback is ranging always between 1.5 to 2.5 years. Scrubbers can accommodate whatever fuel operators burn. If you find the 2.5% sulfur, you can burn it. If you can find the 3.5, perfect. No matter the sulfur content, you can always run whenever you want. Also, the 50% of the installation can be performed during sailing. Some of our latest reference includes Maersk Line as a pilot project for an auxiliary engines. And for an American company, that is Vulika Shipping, it's a new building designed by Delta Marine, and the steel cut ceremony is starting back in November. And the system will accommodate 2 multi-stream hybrid systems from DuPont. Thank you very much.